In this video, I'll be covering some intermediate memory concepts, including memory addresses and offsets. So a quick refresher about memory before we dive in. Memory is stored using binary. It's stored using bits, which are either 0 or 1. A bit is also the smallest unit of memory that can be stored. Computer hardware is optimized to work with bytes. 1 byte is equal to 8 contiguous bits. And the entire memory in the computer can be thought of as one contiguous string of bits. All data in memory has something called a memory address. These addresses are used to locate data in memory. Addresses are always the same, only the data at the address will change. Normally, when you're writing programs, you won't utilize addresses directly, and instead you'll let variables do all the heavy lifting for you. Memory offsets can be used to locate items at a specific address. Offsets always begin at 0, and they represent the number of bytes away from the original address. Similar to addresses, you usually don't deal with offsets directly. Instead, you'll deal with indexes, and the compiler will automatically calculate how many bytes away you are from the original address based on the index. Here we have a basic diagram showing computer memory with addresses and offsets. Each one of these squares represents 1 byte. Here we have the offsets, and here we have the addresses for this particular demonstration of memory. Each byte here can have a memory address. This would be address 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, all the way up to address 20. If we wanted to access this particular piece of data, it would be at address 4 with an offset of 1. So address 4, offset 1. And when you're working with your program, you would usually have a variable name. I just use data as a placeholder. And you would use the index number surrounded by square brackets. If we wanted to access, for example, this piece of data, it would be at address 16, offset 3. So we can access that with a variable name and then 3. Remember that the variable name will automatically take care of the address, and the index will automatically get mapped to an offset by the compiler. So you don't need to know that each one of these squares is actually 1 byte. When you're working with programs, maybe each square is 10 bytes or 20 bytes. That's not something that you need to be concerned with because the compiler will automatically calculate that for you to ensure that you arrive at the correct memory location and have the proper data. To recap, memory uses addresses and offsets. Addresses are permanent, but the data at the address differs. Offsets can be used to index into some data. So when you have a list of items, the index can be used to access individual items within that list.